So let's drop into the adder and subtractor and we'll see how we've implemented this subtraction. So we'll look inside the shifter and inside the adder subtractor and inside the normalization. So inside the shifter here, this is exactly the same as the previous one, so I'll bring up the previous one here just as a reminder. So there's the top level and this is the shifter here, so it's just exactly the same. So we'll head back up and we'll head into the adder subtractor. So the adder subtractor you'll see is a little bit different. So the original one only had this here, okay, so it was just the addition of mx, my, and then we took out bit 24 and 25. But now, not only we have this addition mx, my, we also have to take care of the subtraction. So there's an extra multiplexer in here, and this multiplexer will determine whether we're actually going to pass on the summation of the mx, my, or we're going to pass on this other value here. So this is the addition path here, and this other one out here is going to be the subtraction path. So whenever SZ, so SZ is the, whenever it goes high, it tells us that we're performing a subtraction. So when SZ goes high, it passes out this value here, this out. Now the value out here is going to come from the largest mantissa, the smallest, mantissa value. So the smallest mantissa value is always going to be the my, and you can see that if you open up the spreadsheet. So let's put in a couple of numbers. So let's say we put in 60 minus 5. We can close this here. Now whenever we look at it here, we're going to have the 60 minus 5, and the EX is greater than EY, so we didn't have to swap these round about. We've added in the extra bit here, so this is the hidden bit for 1 for each case. But remember that the Y here now is going to be the value that's going to be shifted. So this is the value that goes through the alignment. So the mantissa becomes smaller. So in this case here, you can see that the mantissa here is shifted by 3 values. So it goes 1, 2, there's 3 zeros, and then it counts 1, 0, 1. So we know that this Y value is always going to be the smallest, and we take the smallest and we find we invert it, we add the value 1 on, and we have this line here, which is line 16, which is the 2's complement. And then we have to add on the other value, which is the Y value. So we've got to go through this, in effect, this addition here. And this addition here for these 2 rows is different from the addition for these 2 rows. The addition in these 2 rows, the addition in these 2 rows here occur whenever we are actually performing an addition. But when we perform a subtraction, remember we're adding on these 2 rows here, rows 16 and rows 17. And you can see that if we head in, we have my, which is the smallest value for the mantissa. It's inverted, we add 1 to it, so we get the 2's complement. We then take this 2's complement and we add on the value of mx, and we get the output. So this is just following exactly the process you see in the spreadsheet. And in fact, what you can do is, and I suggest you do this, you can grab a probe here under the wiring section, and you can stick the probe in, and you can probe each point, and you can compare each point here with each line of the spreadsheet as you work through the subtraction. And you learn a lot by doing that, and I suggest you go ahead and try that out. Now, one other thing to note here is that we took the value for the bit 25 for the addition at this point here. But now the bit 25 can occur at the 2 different points. The bit 25 can occur here at this addition, but the bit 25 can also occur for the subtraction. And again, you can see that in the spreadsheet. If we were to add the 0 and the 1 here, then we would get the bit 25, which would be this bit here. So that would be for the addition. But when we do the subtraction, we're not adding this bit and this bit here. We're going to be adding this bit and this bit. And it's going to give us a different value here, or potentially a different value for bit 25. So we have to ensure that we make a choice between these two bit 25s, and we make that choice here. So whenever the sign goes high, that tells us we're subtracting, then it's going to choose this value here for the bit 25, which you get for here. And when it's adding, we choose this value here for the bit 25, which we get from up at this point. Now the bit 24 still comes off at the same point. So that's the adder. Put some values into the spreadsheet and put a few of the probes in, and you'll work and follow every single line, and you'll see it matches up with each of the lines within the spreadsheet. Now let's have a look at the normalization section. So if we head back up to the top level and we get into the normalize, and again there's a few extra parts have been added here, and you can see from the original normalization section, so that's the original one here, and it's quite small, so I'll take a copy of that so we can refer to it. So that's the new normalization section here, and this is the old normalization section. Now this new normalization section, all it does is follow the truth table that we've seen in the previous video. So we'll bring up that truth table and we'll see how this circuit here follows that truth table. So the truth table at the top covers the addition only. So we've seen from addition that bit 25 controlled whether we passed on the EX straight through and the MR straight through, and if bit 25 was a 1, then it would be passed through the EX plus 1 and the MR divided by 2. And this bit 25 originally went in here, and it just controlled whether we pass the EX and the EX plus 1, and also in the top line whether we pass the MR and the MR plus 1. So that would be purely for addition. But now obviously we're going to pass on some slightly different values because we're going to have to take care of subtraction. So the bottom truth table here was for subtraction, and we said for subtraction we're going to pass on either the cancellation, in which case we get EX minus 1 and MR times 2, or we just pass through the no change, again, which is just the EX or the MR. So you can see that we've added in this extra little bit of circuitry here. So this little bit of circuitry passes on the EX minus 1, so we see the EX minus 1 here. So that passes that on. And also for the mantissa, we're going to have the MR times 2, and this is going to be the MR times 2 here. Now we want to choose this EX plus 1 and the MR times EX minus 1 and the MR times 2 whenever we get the bit 24 going to a 0, and also the value for our SZ, which is tells us whether we're adding or subtracting, that value goes to 1. So we know we're subtracting when SZ goes to 1, and we're interested whenever the bit 24 goes to 0, because that's when we perform this cancellation. And you can see here that we've catered for that with this little circuit here. So whenever SZ goes high, we know that we are performing a subtraction, but we don't get a high output in this unless, of course, bit 24 was to go low. So if bit 24 goes low and SZ goes high, which is this term here, then we get this cancellation. So we mean that this point here goes high and we choose this path here, which is the EX minus 1. And we do exactly the same down here whenever we choose the value for the MR times 2. Now all we have to take care of are the other two lines. So I think it's maybe difficult for you to see this, so I'll put a little pen mark. So we're interested in the other two, which is going to be whenever bit 24 is a 1. So we're interested in this line here and also in this line. So in these two lines here, we're going to have no change. And you can see that we're going to generate that because whenever the value for bit 24 goes to a high, then you can see from here, when bit 24 is a high here, or bit 24 is a high here, we're going to get a low output at this point. So we might get a low output here and a low output here. It means we're going to be passing on the top value, so we're going to be passing on one of these, which was the original addition section, and again we'll be passing on one of these, which came from the original addition section. And you can see that we're going to pass on the value of EX and also the value of MR. So the value here, ER3, will only go high whenever the SZ is a value of 0, that is for addition. So if there's no addition, then it means that this value ER3 will always be low. And the same thing for this control over here for the MR1. So it means that whenever we perform the subtraction, these are always low, this one here and this one's always low. It means we're always going to be passing on the value of EX straight to ER and the MR straight to the MR out, which is exactly what we want. This will pass the value of EX and MR, and this one here will pass the value EX and MR. So this little circuit just performs exactly what we've got written down in this truth table here and also this truth table here. So I suggest you put some values in, again in the spreadsheet, and then put a few probes in, and you follow the logic through the probes, and it'll give you a good understanding, and it'll help you cement your understanding of this little circuit. So that's the main changes covered within the addition and subtraction. Now, one other thing we'll have to note here is that we have to make a choice between the near path and the far path. So the near path is down this side and the far path is down here. And we said that we're going to choose the near path whenever the exponent difference is less than 2. So we get an exponent difference of 0 or 1. So that's a test there to see that that exponent difference does actually occur. Now, that's not the only thing that we have to check, because we will only perform subtractions down the near path. We will never be performing an addition. So it means that what we can do is we can check and make sure that we're actually performing a subtraction. So the SZ will tell us if we're performing a subtraction. So if we're performing a subtraction and the exponent value is, the difference in the exponent value is less than 2, then we will be using the near path. In all other circumstances, we will be using the far path. Now, that's us covered the one half of the subtraction. In the next half, we'll go ahead and we'll cover what happens whenever we get cancellations. So that's the large bit cancellations down the near path. And we'll also explain this add and subtract button, and that'll be us finished with the subtraction process. So that's all for this video. Thank you for listening. I'll get you in the next video. Goodbye.